So coming back to this function and the graph, we know that this is so what are some observations that we have? First observation is that the axis of symmetry, right? The axis of symmetry is dependent on the relationship or the ratio b divided by a. Okay, so this is where the b from the y equal to ax squared plus bx plus c come into play. Okay, so x equal to negative b divided by 2a. The a here, coefficient a, will determine the concavity of the graph. So if a is positive, the graph opens upward, and if a is negative, the graph opens downward. Okay, in this case a equal to 1, so the graph opened upward. The third one is we're talking about now what happened when we have y equal to ax squared plus bx plus c. Now what happened when x equal to 0? When x equal to 0, we have x squared is 0, 0, so we have y equal to c. Okay, so in this case, in this situation, we can conclude that c is the y-intercept, okay, of a graph. So look at this. So our c is positive 4, so the graph cuts the OY axis as 4. So 4 is our y-intercept. Okay, so those are the observation that you need to be familiar with when you do the graphing for quadratic equations. Now we move to the new topic, and this topic has some application that we study about quadratic function. The next section that we have is solving quadratic equation. Okay, solving quadratic equations. So quadratic equations is an equation, right, that can be written in the form ax squared plus bx plus c equal to 0. Alright, where a is different from 0. And this form is also called a standard form of a quadratic equation. So this is a standard form of a quadratic equation. So of course this is a standard, and there are varieties, okay, variation of this standard of this form. For example, as long as the a here, coefficient a, is different from 0, we have a standard. We have the quadratic equations. Couple example we have is 4x squared plus 3, 3x squared minus 2x, okay, negative 5x squared minus 5, and 26 minus 4x squared. Okay, so Like the quadratic functions, you need to be able to point out the a, b, and c of quadratic equations. So very similar to quadratic functions, a is a coefficient in front of x squared, b is a coefficient in front of x, and c is a constant. Okay, so in this case, for x squared plus 3, a, b, and c. So a is 4, b, okay, we don't have bx here, right? So b is 0, and c is a constant number, in front of it is positive, so positive 3, okay? Let's do an example for these. So let's find a, b, and c of each of the following equations. So in this case, a is 3, b, right? Remember the b is a number in front of x, and that includes the sign of it too, right? So it's -2, and c, we don't have c here, right? So c is 0. A, -5, b, there's no b, right? So bx, right? So 0, and c is -5. Now, how about the last one? The last one is actually a little bit of a tricky question, but if you remember that the a is a coefficient in front of x squared, okay, so in this case our x squared is actually written in second, okay, but a here in front, coefficient in front of x squared, and this is -4, okay. I've seen a lot of people in class, they immediately write 26, and this is not correct. 26, okay, there's no x next to 26, so this is actually 26 is a constant c, so constant. And b, again, here is the bx, right? So the number in front of x, and we don't see any x here, so that means b equal to 0. So each of these quadratic equations can be solved by a variety of methods, including graphing and finding square roots. Okay, so in this chapter 9 we will learn about these techniques. But for first very basic techniques is graphing. Okay, so solve equations by graphing. So in order to solve the equation, we need to graph its corresponding function for that. Okay, what does it mean by that? Let's say that I want to graph the function. I want to solve the equation x squared minus 4 equal to 0. Okay, by graphing. Okay, we know that the quadratic equation has its own related function, okay, and its related quadratic function is y equal to x squared minus 4. Okay, we know that the solving the function means solving any equation. Solving equation means you find any values of x that make y equal to 0. In other words, okay, so this is a equation part. But how does it translate into graphing? What it means is that the x values any values of x that makes y equal to 0. In the graphing language, it means that we actually find the x-intercept, right? The x-intercept of the graph toward the OX axis. Okay, so here are the two x-intercept. Okay, so the first step of solving quadratic equation by graphing is that you have to graph. So the first part is you have to graph this related function y equal to x squared plus minus 4, and then the second one is you have to find the x-intercept. Okay, you have to find the x-intercept of the graph, and then the solutions of quadratic equation and the x-intercepts of the graph of related functions are called the roots of the equation. Okay, so when you talk about roots, it's equation. But then when you talk about the graphing language, it's called the zeros of the function. Zeros of the functions. Because the zeros here are the x values or the x-intercepts that make the y equal to 0. Okay, so both way of saying it represent the solutions of the equations. Okay, so let's do a quick example for this. Now, suppose that I want to solve the equation x squared minus 4, alright, by graphing. So first part is I know that I have to graph y equal to x squared minus 4. So graphing this, I know that a is positive 1, so it's concave up, right? And then the vertex of this, vertex x equal to negative b divided by 2a, and I know that there's no b, so b0 here. 0 divided by any number is 0, so this is 0. X equal to 0, y equal to negative 4. Okay, so 0 and negative 4 is my vertex. Okay, so is the vertex, is the first vertex of the graph. Okay, so 0 here, negative 4, negative 1, negative 2, negative 3, negative 4. So negative 4 here, negative 4 here, 0, negative 4. This is the vertex. Okay, and I want to find the other points as well. So I make a table of values. I have x here, y equal to x squared minus 4 here. Let's say I choose point, let's say 2. 2 here we have 2 squared minus 4, which is equal to 0. Okay, so x equal to 2, y equal to 0, so this one here, and I know that the axis of symmetry is actually OY, so I know that from here I can also find the negative 2 is the second point. Okay, so graphing this, and I see that negative 2 and 2 are the two x-intercept. Okay, negative 2 and 2 here are the two x-intercept for this quadratic graph, and I can conclude that the 0 of the functions are negative 2 and 2. In other words, solutions of these equations is negative 2 and 2.